Stress-strain curve. In this video, we will discuss the relationship between stress and strain when a body is subjected to an external loading. When a deformation load applied over a body, an equal and opposite restoring force will be generated inside the body. This restoring force per unit cross-sectional area is known as stress. Similarly, the deformation cost or ratio of change in dimension to original dimension of the object is termed as strain. Stress and strain developed in the body can be determined experimentally by means of load testing with the help of universal testing machine. In standard experiments, strain value will be plotted along x-axis and the same time y-axis will be representing the stress value. When a body subjected to loading, stress and strain value increases from the origin and reach at a point A. From point O to point A, it is evident that stress and strain is in linear proportion. That means stress and strain are directly proportional to each other. Hence, this limit also known as proportionality limit. Adding with this, within elastic limit, the ratio of stress to strain is a constant which is popularly known as Young's modulus. Young's modulus can easily calculated from the slope of this line. You can also note when an external loading removed from the body within elastic limit, it can regain its original shape without an external force. When we keep increasing stress value from point A to point B, the body starts to yield, hence the point A known as yield point. During this transition, the deformation cost cannot be regained without an external force. Hence, we will experience a permanent deformation in this region. If we keep increasing the stress value, it is observed that from point B, the body will experience further reduction in its stress value. Or other words, point B represents the maximum stress or ultimate stress that the body can generate. Further increase in stress will make abrupt change in strain and leads to the fracture of the component. From point A to C, we experiencing a permanent deformation which cannot be reversed without an external force. Hence, this region is known as plastic region. Now let us discuss how to extract stress and strain value from standard curve. As you know that strain is plotted along x-axis and y-axis represents the stress value. Let us assume a point M on the curve. It is recommended to use a graph paper to obtain accurate values. Now let us project point M to x-axis. Then project the same point to y-axis. The value of stress on point M can be extracted from y-axis. Similarly, the value of strain will be indicated on x-axis. The units of stress can be calculated as per the experiment and according to the range of values. As you are aware, there is no dimension for strain value. However, you can arrange the fraction according to the requirement.